Hello and welcome to another LLM open source model comparison. Today we are putting Kimi k2.6 up against GLM 5.1. So Kimi k2.6 was launched a couple days ago and has really impressive numbers. I recently made a video where I put it up against Opus 4.7, and I have to tell you that I was really impressed at how much of a punch k2.6 packed. It gave Opus a run for its money. I'll tell you that much. If you don't want to see the entire video, k2.6 won, but I do think you should go take a look at the video to experience how far we've come and how well the model performed against a state-of-the-art model such as Opus. Now, that being said, of course, I expected Opus to put up a good fight because it is a state-of-the-art model. But today we're putting Kimi k2.6 up against GLM 5.1. Now, GLM 5.1 is also an open source model, and it was released about 2 weeks ago. And I put up a video where I had GLM 5.1 against Opus 4.6 and GLM 5.1 against Qwen 3.6 Pro. These are really fun videos to make and also really surprising and impressive results. I suggest you go take a look at them to see how well GLM 5.1 performed. So I have taken the time to put these models up against each other, run a bunch of tests, run a bunch of prompts, and I am fascinated by the results. I do think you will be slightly surprised as well, but I'll go in saying that I think GLM 5.1 might have been nerfed. I'm not sure what it is, but I'll just say it didn't perform as well as I expected going into this test. But without wasting much of your time, let's go into the first prompt, the first test, and see how well GLM performed. So the test I ran here is very similar to the test I had run with k2.6 versus Opus 4.7. So nothing too crazy. It's just a very cool litmus test to see how well these models are performing. So the first test is a simulation prompt. So we're building a fluid simulation. It took taking Kimi 5 minutes to run that. And it surprisingly took GLM about 1 minute to get it done. So also worth noting that it was cheaper on GLM relative to Kimi k2.6. Now let us go and see the front end results. All right, so this is the particle simulation on Kimi k2.6 right here. And this is what we have going on. And honestly, I just want to jump into GLM 5.1 because I have no idea what it is doing. The particles are all over the place. Gravity rarely works. Repel, attract, nothing works. The particles are losing their mind. The viscosity, I guess you can see that at the edge, but it's bad. It's just bad. And this is Kimi's version. It's still, it was nowhere as good as Opus, but it's decent. You can tell that things are happening. Like gravity responds. You can see the particles going back up, resisting gravity. And even when I turn gravity up or I turn it down, nothing happens with GLM's version. So it's pretty obvious that Kimi k2.6 wins the first round. I really had hopes, honestly, because GLM 5.1 is a really good model. It just seems to fall apart for whatever reason. But this is the first prompt. Let's go on ahead and check out the second prompt. So the second prompt, the second test, is getting these agents to build out a solar system, NASA-style mission control user interface, right? It took Kimi 11 minutes to get it done. And it took GLM 1 minute. That's strange, but I guess that's how long it took it to get done. Let's go ahead and see the result. So because I've carried out this test before, I have seen how it looked when the comparison against Opus. I'll start with Kimi's version, just so you know what to expect, right? This is the solar system user interface going on. It works. We're able to move things around. We're able to select planets, like Venus comes here, and we're able to see the orbital parameters. We're able to see the details, its classification, its orbital period, equatorial radius, and a bunch of really fun statistics, right? A bunch of really fun data. We're able to see that. We can dismiss, it takes us back, and we can just play with it. If this is Earth, we can take a look at Earth. Its orbital period is about 365 days, fairly accurate. And we have these cool things we can just work with, right? When we head over to GLM's version, I'm not sure what to make of it. I think it works, but like it doesn't look great. Well, yeah, it doesn't look great, and I can't. And this is Mercury. So its orbital parameters, physical properties seems to be fairly present. And as opposed to being able to click on the planet, I think I can, but it's moving so fast. And the planets also don't, like Earth doesn't have a, really nice looking design. It's just a dot. It's not looking really good for a GLM here. And to navigate through the planets, we just click on them right here and we get the physical properties. But the user interface, the design in and of itself, leaves a lot to be desired. I'll say that much. Kimi k2.6's version is just superior. It's just better. It just looks better. It functions better. Kimi wins this round again. So that is 2-0 Kimi versus GLM, and Kimi is taking the lead. Now, there are a bunch of other prompts or other tests that I wanted to run on GLM. I'm not sure what the issue is, but I could never get open code or open router to work. It just kept failing, and I've been running these tests for hours on end, and it just never really worked. I really wanted to see how well GLM will build out the Pathfinder race test, but we can't really see that on here. But this is what it'll look like. So if we were to reset to this and click on race, what's happening is we built like a maze, and this dot is going to figure out how to get here if there is an actual path. And when I click on race, it's just going to navigate its way to get here. If I reset and I block all the possible paths, it's going to find somewhere else to get there. When I built this with Opus, it was really cool. The user interface was fairly different, but it was also pretty functional. And when there is no path, it just says no path. So it's not able to get there. We can't see how well GLM would have built that out because OpenCode just refused to work for whatever reason. I'm not sure if it's an OpenCode problem or if it's an open router problem, but it just didn't work. So moving on to the third prompt, the third test. This one is pretty cool because this is a dashboard UI I got off of Dribble. Nothing too crazy, just downloaded it. I pasted this and I asked the agent to build this out. So just like basically build this out one shot and see how well they'll both perform. And we will start off by taking a look at Kimi's version. First things first, you could see how similar they both are, to an extent at least. They look pretty good. It works well. Nothing breaks, at least on GLM's version. We can see Kimi messed this up, so that didn't turn out really well. But as far as like the entire UI goes, they're fairly consistent. And GLM wins this one for me. I know that Kimi k2.6 would have done a better job if I gave it another try, but we're not doing that. It's one shot and seeing how well they perform. And GLM it wins. This is good. It's usable. We could definitely, narrow down the prompt to get it to build this exactly as we wanted it to. But this is what we get, and it is functional. It's pretty good. So that is 3-1. GLM wins this round. We're going to go on to the fourth and final test, which is a remotion test, which happens to be my favorite test. I've said this all the time. Opus 4.6, 4.7. Opus takes the crown when it comes to building out remotion components. Open weight models, GLM, Quen, Kimi, they do a pretty good job, but they just miss something. They never really get it together, and that blows my mind all the time. So I'm going to show you the differences between Kimi's version and GLM's version and what to expect when sort of working with these models. Let me know if you want to see a detailed sort of remotion comparison between all the open weight models and see how well they perform. But this is the results for these models. We're going to play GLM's version and see how well it performs. So we have that, and it looks pretty decent. I wouldn't call this usable, but like, it's great. It's fine. And this is Kimi's version. They're fairly similar with how they handled, the date duration and also this design. A lot of similarities between both of them. And I say that and a lot of similarities between both of them. Now, this is Opus's version. So you can sort of tell that it is different because I ran this test and like, this is what I got when I gave the exact same prompt to Opus. As you can see, first off, the date is different. The design here is different. And this is also different. So the way the open weight models approach remotion design tends to be the same, and Opus's is just very different. So I'm not sure why that is. I'll probably do some digging to figure out why open weight models sort of end up looking the way they look. And Opus's version is just different. So that's pretty much it. This is a quick overview test of what to expect when you are making use of Kimi k2.6 versus GLM 5.1. I am Kimi pilled. Kimi is my favorite model right now. I don't think I'll be making use of any other open weight models as far as like day-to-day task, OpenClaw, Hermes agent. Kimi k2.6 is my agent of choice, and it just works. So we ran 5 total tests, and Kimi k2.6 wins 4 out of 5, and GLM wins 1 of them. And the winner is Kimi k2.6. So when you're sort of building things out and working with these open weight models through OpenCode, because OpenCode is a harness I made use of for this test, Kimi is going to do a better job more often than not, at least one-shotting your agent. And GLM is pretty good. I think if we guide the agent a bit more, it's going to perform even better. Considering that they are both open weight models, Kimi wins. They're working on fairly even ground, and Kimi just takes the crown. So yeah, that's pretty much it. This was supposed to be simple and straightforward. I hope it was helpful. And if you like this video, please give it a like. If you want to see more comparisons like this, leave a comment. Let me know what you'd like to see, and subscribe to see more of these videos. Thank you for watching. I'll see you in the next one. Peace.